I mean, basically, I want you guys to be the best versions of yourselves, okay? You know, so, and sometimes that means getting lots of sleep. Sometimes that means not finishing all of your homework. And I want to give you permission to tell yourself it's okay. I know, like in high school, like not doing my homework, that was like crazy tough. But you know, of course, I want you to do your homework. I think doing the homework is a good thing. It's like I want you to go to the gym. I think that's a good thing. But also, if you can't do it, something comes up, you know, it's important to be a good friend, right? If your friend is in need of comfort or something, you know, it's okay to be there, right? And maybe that means giving up your own time that you would have spent doing something like homework or doing something for yourself in order to be that good friend. And I want to give you guys permission to do that, and I think that's a good thing, okay? Anyway, that's beside the point. All right. So we're talking data visualization. We left off on Monday, and reminder, daily symptom monitor survey. Okay, so if you haven't done this, go ahead and do this. All right. You know, I checked the other day, like, because they have like a faculty portal where you like check, and it's like, did your students fill out the survey? And I was like, only half of you filled out the survey last time. So just a reminder, please do that. Okay. Okay, so we left off on Monday, and we didn't get to go over this part because I was talking too much. Story of my life. This section is just about like, okay, here's a graph, and let's talk about the elements of this graph, right? So what's happening here, right? What's on the vertical axis? What's on the horizontal axis? What kind of variables are we looking at? What's the coordinate system we're looking at? What's the scaling system we're looking at? What's the context of this, right? Is this a good graph? Okay, well, is it a good graph? That's a harder question to answer. But there are good elements here, right? It's got some context, right? You see this? It's got a title. Average SAT math score, 1994, 1995. Okay. That gives some context. So this is like, what is that, 26 years ago, 27 years ago? So this was a while ago, and we're looking at, okay, this must be the average SAT math score. Okay, that's what the title says, right? And then on the left-hand side, we have a axis, vertical axis starts at 200 at the bottom, then 300, 400, 500, and we can see because the spacing between 200 and 300 is identical to the spacing between 400 and 500, this is a linear scale, right? And so, and then we have these bars. So the height of the bar indicates the average SAT math score. What's going across the bottom? Across the bottom, we've got state names. We've got Connecticut, Delaware, Maine, Massachusetts, New Hampshire, whatever it is, okay? So this looks like things in the kind of the Northeast. And we're looking at, presumably, we don't know exactly what group of people, but I guess people who took the SAT, and I guess, you know, College Board is keeping track of this, and they said, hey, what state are you from when you take the SAT? Or where did you take, I don't know where it is, okay? And then we have this, right? So this horizontal axis is used to denote the categorical variable of which state, okay? And it's a categorical variable, so we could actually, you know, it's in alphabetical order, but we could have arranged this some other way, right? We could have put the tallest on one end and the shortest on the other end, and something like that, okay? So when we dissect this and talk about this, we got, this is kind of what we've written there, right? And the vertical axis begins at 200. Sometimes you'll see different graphs. I want my stick. Sometimes you'll see different graphs where this vertical axis, this part, you know, starts at 0, which makes sense for a lot of cases because 0 is the place where you want to start. Other times, it starts off at some arbitrary, misleading number, just to kind of, like if we started out like 450, it would really make the difference between like 450 and 490 look huge, okay? So, you know, perhaps you want to emphasize that, perhaps that's a misleading thing, okay? Here's another plot, okay? There's a lot going on here. All right, so it looks like this is world record time in the 100 meters freestyle. It looks like we only have data up and through like 2000 something, and these world records have been broken. Okay, so you'd have to see 100m freestyle, and some of you might recognize, okay, that's got to be swimming. Okay, that's like the only time we talk about freestyle, unless we're talking about like dancing or something like that, right? So so swimming, 100 meters freestyle swimming. This is the world record time. We have it split between female and male world record times. And so we can see that in 1900, this is how fast they swam, and then, the world records get faster and faster. Okay, this would be an indication, this long break right here would be an indication that this world record was not broken for many years, okay? Also, the fact that they're connected makes it all the more apparent that the times get faster, which of course makes sense. If you're talking about records only get broken to be faster. Your record time doesn't ever go backwards, right? The world record there. So, and again, the coordinate system on the x-axis is linear. Coordinate system on the vertical axis also linear. So this is a Cartesian coordinate system. It's probably the more common coordinate system that we use. Okay, so all of this is just in text what I've been saying in words. Okay. Okay. The importance of data graphics. All right. So the Challenger disaster, 1986. The space shuttle program is still pretty young. Did you guys ever? There was a Netflix documentary on the Challenger that came out like during the pandemic. It was very compelling, and they talked about what happened. So the space shuttle program was rather new, and then and maybe about a few years into the space shuttle program, the Challenger shuttle exploded, and it was they actually had a civilian teacher on the space shuttle at the time, and it was kind of a big deal, and it was like broadcast because it was like teachers in space, and this was this very exciting thing, and so it was broadcast to all of these classrooms. And so I was too young, but if you talk to probably people in their 40s who were students at that time, they might recall that this was like this traumatic memory because they're all in school, it's being broadcast on TV, and as it's being broadcast, the shuttle explodes. And the problem after the fact, when they studied it, it was the fact that it was very cold that morning, and when it was very cold, it compromised the quality of the rubber seal, the O-ring seal on these rocket boosters, allowing fuel to leak and allowing it to, and which eventually caused it to explode. And the problem was that they had discovered this problem earlier. Okay, they were aware of this issue. Okay, but the graphics used to convey this information was bad. Okay, this was one of the graphics used, and they were talking about, okay, the information here is what we see are so each of these things. There's two. They're labeled 12, 12, 11, 11, 10, 10. These are different shuttle launches, okay? And this was the temperature at the time of the shuttle launch. This one was 78 degrees here, okay? This shuttle launched 63 degrees. This shuttle launched 57 degrees. This shuttle launched 70 degrees. And then if you see a little marking on the booster, that means there was damage discovered. Okay, damage discovered after the fact. Okay, and so they say, okay, there was damage here, there was damage here, and what they were trying to say is that when it's colder, that this graphic is trying to. Well, when you look at this, what do you take away? It's hard. It's hard to interpret this, right? We see a bunch of rockets, we see some markings, and we go, okay, yeah, sometimes things were damaged, and someone says, no, if you look. on the colder days, 57 degrees and 53 degrees, there's damage, okay? And so we go, oh, look at this one. This was 75 degrees and there's damage, okay? So what's the point you're trying to make, okay? This was the table, they said, okay, you know? Look, on when you had degrees here, we had this kind of, these kind of problems here and stuff, okay? And we're looking at this. I'm sorry, I think I saw a hand raised. I don't know if there was a comment that somebody wanted to add. Okay. So with this, the managers were like, I don't know what point you're trying to make, okay? Right? You're saying when it's colder, there's more damage, okay? Maybe, but also 75 degrees, there's also damage, and yeah, you know, we don't really know, okay? So if they had presented the data a little bit differently, it might have become more clear, okay? And so this plot just shows across the horizontal axis the temperature, okay? And the plot over here this is kind of some way to kind of express the amount of damage discovered as a numeric variable, okay? The higher the numeric variable, the more damage there was to the O-rings, okay? And so what we see is that, you know, most of these temperatures, okay, in the 60s and 70s, things like that, very little. Yeah, there was some damage here, and yes, there was some damage here. But what do we know? As we go further down, lower in temperatures, we can see, oh, you know what? There's more damage. As we get colder, there was even more damage, okay? So this, I think, starts to convey what's going on, okay? The morning of the Challenger disaster, this was the temperature. The temperature that morning, 26 degrees, 29 degrees. That was the forecasted temperature for that morning. And we could see there was no data even close to being recorded at this time. And so, you know, it's hard to know how to extrapolate from here to here, okay? But if you say, okay, well, what if we just continued this line? We could see, okay, there's a, you know, this would be very high. And just the fact that pretty much every other shuttle launch happened in this kind of temperature range, and then we were considering, or that the Challenger was being launched in this temperature range, 26 to 29 degrees, that should have been an indicator that, you know what, we've never done anything like this. This could be a dangerous scenario, right? And I think a graphic like this is much more compelling than seeing something like this, right? And this is the importance where data graphics come in, right? Somebody could have been very proud of themselves. Hey, we figured out a way to get our little booster rockets to look like booster rockets in our chart, right? And we could show exactly where the damage is occurring, okay? And they might have felt very proud about that. But the fact is the important information, which is the amount of damage that happened and the temperature at that time, is kind of lost in this kind of chart, okay? Something like this makes it a lot more clear. Something like this also makes it much more clear that we're entering uncharted territories, okay? And, you know, of course, in hindsight, everything is easy to spot and see where the mistakes and the breakdowns go, but this is often used as an exercise to kind of illustrate when what you're trying to say and what you're trying to communicate is not made clear in the graphics, that point could be lost. That point could be lost, okay? The engineers were aware that colder temperatures cause problems, but it wasn't clearly communicated enough, okay? Okay, first view quiz answer for today is the letter A. A as in apple. A as in apple is our first view quiz answer for today. A as in apple. Okay, so I'm going to introduce ggplot. This stuff comes from, these slides are based off of this textbook, the R Graphics Cookbook. Chapter 3 in Modern Data Science with R also does a good job of introducing ggplot, and you know, please be sure to do your reading there as well. Whether you do it before or after class, you know, it doesn't really matter. But yeah, do read this. And there's a link to the textbook. You can get the physical book, or you can also just read it online. And I'm actually using a lot of these slides. I used some of these same slides in 102A. So if you ever take 102A again with me in the future, you're going to see some of these slides. And my apologies for recycling content. But I think this is a good introduction here. And it feels a tiny bit strange for me to introduce ggplot at this point right now, because we have barely even covered like R. I haven't even talked about R. I know I assigned a little bit of homework from data camp introducing some basic concepts of R. But here, again, we're using R mostly as a tool to get what we want, to explore data. And so we want to start off with, hey, how do we even just create graphics in the first place? Okay, and that's where we're kind of starting here, all right? And so there R has what we call base graphics capabilities, okay? There are already functions in R that allow us to create graphs and charts, and we call that base graphics, and they're great, okay? They're great, I use them all the time. But one thing that's really nice about ggplot is that it has kind of this, it uses what's known as the grammar of graphics, okay? The package is created by this man, Hadley Wickham, who is like very, very, very important as far as R packages goes. It's part of something known as the tidyverse, which is a set of packages kind of created by him. And then this other person, Leland Wilkinson, created something called a grammar of graphics. And this person thought about like what exactly is happening when we create a graph and what's going on there, and said, hey, we should create a plotting system based on that, okay? So I think I said this on Monday, but when we create a data graphic, what we're doing is we're taking properties of the data and we are mapping them to visual properties of the graphic, right? So we're taking some value that appears in the data, you know, maybe the average SAT math score 500, and we're putting it to a visual property. That number 500, well, it should go at this height in the graphic, okay? This other number, 450, it should go to this height in the graphic, okay? This value comes from Connecticut, it should go over here in the graphic. This value comes from Vermont, it should go over here in the graphic, okay? This was the freestyle time in 1975, okay? It should go right here horizontally. The freestyle time was, you know, 50 whatever seconds. It should go right here in the graphic, okay? And if we're not mapping the data to some visual property, it's not a data visualization. It's just a picture of something else, okay? So here I'm gonna just start off with a very, very, very simple table of data, okay? 4 columns, and these are imaginary people, okay? We've got 6 imaginary persons with in 4 columns, okay? And we're looking at the people's heights, their weights, their genders, and their hair color, okay? And so, you know, this is how you might create a table. We call this a data frame in R. And again, don't worry so much about this. I mean, this will become familiar. You guys learned how to create vectors, right? In your thing, right? So you create a vector. And then basically, so each vector becomes a column. And if you kind of say, hey, I want the name of my vector, this vector to be called height, I want this vector to be called weight, I want this vector to be gender, and this vector to be called hair, you wrap that in a function called data frame, it basically makes a little table here, okay? And we call these things data frames, okay? We'll get to this later, but a data frame is not a matrix. A matrix is numbers only or characters only. It can only have one type of data, generally numbers, okay? A data frame can have columns of numbers, but also columns of text, which is what we see here. Okay, and so when we create a plot, we are going to map each of those columns to a different visual aspect. We're gonna say, hey, let's take height, put it on the x-axis. Let's take weight, put it on the y-axis. This is gonna determine where and why it goes. Let's take the gender. And here in our data with our 6 people, we have males and females. Let's map that to the color that we're gonna use. Let's take the hair color, okay? And we have brown hair, black hair, blonde hair. We have 3 different hair colors represented here. And that's gonna get represented with the shape, okay? And so what we see, the resulting plot looks like this, okay? We've got different people. We have 3 different shapes for hair color. Circles represent black hair, triangles represent blonde hair, squares represent brown hair. And then the colors, red dots for females and teal, aquamarine, I don't know whatever color this is, teal dots for males, okay? Blue, green. And again, the height determines where in the X direction it goes. The weight determines where in the Y direction it goes. Okay? And this is this, right? And the key part of the data graphic is that, so if I give you this thing and I say make a data graphic, you could produce this. But also, just as important is that if you give somebody this data graphic, they can recreate the table, okay? If we look at this, and I say, give me all the information about this triangle up in the corner. This triangle up in the corner, we'd say, okay, what is their height? Their height is 72 inches. What is their weight? Their weight looks to be 190 pounds. What is their person's hair color? This person is blonde, okay? And what's their gender? Their gender is male, okay? And so and we can go through all 6 data points, and we can recreate every piece of information for them, right? And so we can find that person 72 inches, 190 pounds, male, blonde hair, okay? And we could do that with all of the data points in this thing, okay? Now, if I had taken away, right? If you remove, like if you did not include this legend over here on the side, you would not be able to recreate the data, right? Without this guide over here, which is this is what it's called, a guide or a legend, you would not be able to recreate the data. And so including the guide is just as important, okay? These lines and the tick marks and the labels, the numbers labeled on the axis are also guides. If I had removed these numbers from the horizontal or the vertical axis, you would not be able to recreate the data, right? So just as important as going from the data to the graphic is the ability to go from the graphic back to the data. Now, when you see a graph, you're not doing this mentally. You're not saying, okay, person is this and this and this. We're taking, we're harnessing your visual capabilities, and you can go, oh, okay, you know what? We're seeing this overall positive trend, positive relationship between height and weight, and we're asking different kinds of questions and stuff like that. Okay. And so we have that, okay? So some of the terminologies we have, the data is what we want to visualize. It's got the variables. They're stored as columns in the data frame. We have things called geoms. These are geometric objects, right? Right now, the geometric objects are basically little dots. We call them glyphs, okay? Glyphs. And right now, they are circles, triangles, and squares, but they could be other things, okay? They could also be things like bars, which we saw. They could be lines. We've also seen them. Okay. The aesthetic attributes. These are the things that we map the variables to. Things like, will the variable determine the x or y position? Okay. The variable determines the shape of the point. The variable determines what color to use for that point. Okay. And we map which of these variables get mapped to which aesthetics. And that's basically what's happening with the data graphic, okay? The scales and the guides are used for going back from the graphic back to the data. They're important for the user to see them so they understand, oh, the circles represent this hair color. The triangles represent this hair color. This color represents this gender, and things like that, right? So we need those guides, we need those scales to help the viewer. And then, the scale controls the mapping from the data. How, do we do this in a linear fashion, in a logarithmic fashion? I'll show you some examples. Okay, So in our example, this is what we did. We had height go to the X, weight go to the Y, gender goes to color, and hair goes to the shape of the point. And this was, and when ggplot made the thing, those scales were kind of determined automatically. ggplot does a lot of this stuff automatically. They said, oh, you know what? The smallest data value you have is like 60, and the highest data value you have for height is, I don't know, 100 something else. And so it determined, you know, I guess 190, and so it determined that the vertical, that the limit should be here. Okay, so ggplot kind of determines this automatically for you, which is nice, because if you were to do something manually, you might have to set these scales up yourself. Okay. And then again, the guides are also automatically created by ggplot. But you know, all of these things you have the ability to control manually yourself. You say, you know, I want a different kind of scale. I want a different kind of guide. You can set those things. Okay. I want to talk a little bit more about this aesthetic mapping. This is what we've created, but we can map things differently. All right. So what I had was I mapped gender to the attribute color, okay? And I mapped hair to the attribute shape, right? And so we had 3 different hair colors. We had black hair, brown hair, blonde hair. We had 2 genders, female and male, and so we have 2 colors, because gender got mapped to color, and we have 3 shapes, because hair color, there's 3 shapes, and we have 3 different shapes here, okay? What if I swapped these around? What if I mapped hair color to color of the point, and gender to the shape of the point? How many colored dots would we have? How many shapes would we have? Yeah, we would have 3 different colors shown on the plot, and we would have 2 different shapes, okay? And so this is what the resulting plot would look like, okay? We have triangles for males, circles for females. We have the 2 people with blonde hair and green, the 2 people with black hair and red dots, and the 2 people with brown hair with blue dots. Okay? These are the default color choices when you have 3 colors. Okay? Now you might say, well, you know what? I should have picked colors. You know, I should black hair should be black, blonde hair should be, you know, kind of a yellow color, and brown hair should be a brown dot. Okay, fine. Okay. But this is, go ahead. This is the exact same data, right? If I gave you this and I said recreate the table, you could do it. If I gave you this and I said recreate the table, you could do it, right? It would recreate the same thing, right? But what you take away from this thing, what the patterns you notice here might be a little bit different from the patterns you notice here. One thing that stands out a little bit more to us, especially with these 2 categories, right? The shape is something that our eyes don't pick up on very quickly, right? We don't quite pick up on the square, circle, and triangle very quickly, and we don't quite pick up on this, right? So if I said, you know, overall, are males or females taller? It's a little bit harder to see, okay? Here, overall, males or females are taller. You can say, okay, well, you know what? As far as males goes, the blue dots, they're more on the right-hand side. The red dots more on the left-hand side. Okay, so you can kind of say overall, the males are taller. Overall, the females are a little bit shorter, at least in our data set, okay? If we ask the same question, you could still pick that out. It's just not as apparent just because the circle and the triangle, this is not something that our eyes really gravitate towards, okay? So mapping them differently results in, you know, kind of different impressions, even though the same data is there, okay? Is that okay? That the same data just gets mapped differently and it produces a different graph, okay? Okay, what if we did this? What if we mapped hair color? Okay, so hair color is black, brown, blonde, or whatever it is, okay? We have 3 settings. What if we mapped that to the Y? Would that work? And then we took weight, which goes from, I don't know, 100-something pounds to 190 pounds. What if we mapped that to the color? Could we do that? Is that possible?
Here is like categorical variable, so we can.
Yeah, here's a categorical variable, and are we going to put it on the y-axis? Weight is a numeric variable. Can we put it on color? Okay, well, ggplot says, that's what you want me to do? I'm going to do my best, okay? And it does. It actually pulls it off, okay? This is what it looks like, okay? What has happened, okay? Brown hair gets a spot vertically, okay? Vertically, we have one row for everybody with brown hair. We have one row for everybody with blonde hair. We have one row for everybody with black hair, okay? Just like nobody had an issue when we were talking about the SAT math scores and we had the categorical variable of where the state was. Nobody had an issue putting the states across that categorical variable across the horizontal axis, okay? And if I just flip that bar chart on its side, that categorical variable would also be on the vertical axis, okay? And so you can put categorical variables on the vertical axis. It's just, should brown hair be here and black hair be here and blonde hair be here, or can I switch the order around? And the thing is, with a categorical variable, you can just rearrange these things. You can put them in alphabetical order. You can put them in some other order, and that's valid, okay? So when you put a categorical variable on something like the x-axis or the y-axis, you could rearrange them, no problem, okay? Numeric variable, they're stuck. You got to stick to the arrangement of numbers, okay? But you can take a categorical variable and you can put it on a vertical or horizontal axis, okay? What happens to weight? Weight being a numeric variable, we're using a gradient scale for the color. We said, okay, people who weigh a lot, they're going to get colored brightly. People who weigh less will get colored dark, okay? Now, because of the quality of this projector, all of these things look the same color, and so it's a little bit unfortunate. On my screen, it looks a little bit better. And if I gave you the graphic on my screen and I said recreate the table, you could kind of do it. It would be a little bit harder. The values you would write down for weight will be a little bit off, right? Like you would say, okay, how much does this person weigh? And you'd go, maybe 160 pounds, maybe 170 pounds. You're not quite sure, okay? But you're going to get somewhere in the ballpark, okay? And so the idea is that same data is still mapped to the graphic, and it's just represented a little bit differently, okay? And this is basically what a data visualization is, right? We're taking aspects of the data, and we're mapping them to visual properties, and we can map them sometimes in ways that we weren't expecting, sometimes in ways that we might think is a little strange, like putting a categorical variable on something that we normally think is for numeric values, and taking a numeric value and putting it in something that we often think is categorical. It's okay. It's okay to do that. And the question is, what is it that you're trying to communicate? What's the most important thing that you're trying to communicate? And you want to think about that, and you want to produce your graphic to fit that. Okay. But yes, if I gave you this, you could recreate that table, maybe not with 100% accuracy because the color estimates would be a little bit off, but you could still get something close. Okay? So on the surface, representing a number with a y-coordinate system may feel very different from representing a number with a color. But at some abstract level, which is we're taking data properties and mapping them to visual properties, it's the same idea. Just what color are we using? What shape are we using? What line thickness or whatever, you know, what visual attribute, visual cue are we doing, okay? Some aesthetics only work with categorical variables such as the shape of a point, you know, triangles, circles, squares. It doesn't really, we can't really do a numeric thing to that, okay? Categorical continuous, like X or Y position could be categorical or continuous, which we saw, and color can also be done that way, okay? You know, when you do something like the bar graph, the x-axis will often be categorical. For a scatter plot, the x and y-axis are usually numeric. Although, yeah, okay. I got this section on ggplot versus base graphics. all to say is that if you wanted to produce a similar plot using basegraphics, it's a lot harder to do. Okay, I threw up this code here. You don't have to, if you don't understand the code that appears here, don't worry about it. But basically, you can just use the internal plot function. There's also a legend function. And honestly, the point of this slide is to show you it's a pain in the butt. Okay? It's not that I actually want you to learn this, all right? But there might come a day where you have to like use basegraphics for whatever reason, and you're like, oh yeah, what he said was right. It's kind of a pain to do. Okay, yeah, question.
Where is ggplot? Is it in the...
So yeah, where is ggplot? That's a good question. So the way it works is you start up R. Here, okay, let's see. So all of my slides, by the way, are produced in R, okay? And the way you get ggplot is you call library, okay? So well, first of all, it might, if you don't have it installed, the first thing you have to do is you have to do install.packages, parentheses, quote unquote, and the package name is called ggplot2. Now, you can also just say, I want to install the tidyverse, and the tidyverse will install a whole bunch of packages, one of them being ggplot. ggplot2 is the name of the package, ggplot is the name of the function. Okay, so you do install.packages, you do this right into R. You only have to do this once. Okay, once you've done it, you get it. Okay, now you can do it again if you find out there's an update, and there's frequently updates, so it's a good idea to do this regularly. Okay, if you forget like how to type install.packages, you can also come over here on this tab packages, and you could say, oh, I want to do the tidyverse. And you click tidyverse, and you can say install or update or things like that, okay? And then to load it, so you can use it, you have to load the package, and you call it library tidyverse, okay? So you can think of it as like, I don't know what it would be comparable to. It's like inserting a cartridge into your video game system or something. Okay, so to load it, you call library. You say library tidyverse or library ggplot2, and it will do that. Okay, and it will load it in there, and then you can start using these things. Okay, if you forget to call in library ggplot, and you try to use ggplot, it's going to say, I don't know what you're talking about, okay? I don't know what ggplot is. And you guys say, oh, yeah, I got to load this library, right? Okay, so anyway, these slides are just here to say it's a pain to do in base R. Okay, let me give you your second view quiz answer. Second view quiz answer is the letter B. B as in bear. B as in bear is your second view quiz answer. Okay, I'm going to run out of time. I'm not going to get through all of these slides. I've got 85 slides. I'm at slide 42. That's okay. I want to talk about building up one of these things from scratch. Okay, so first of all, here, starting point. Here's our little imaginary data frame. Okay. 6 people, 4 variables. Okay. The very first thing that we wanted to create a plot in ggplot, the first thing we do is we say, all right, we want to create a plot, and the data that we're using is the data frame. Okay, so this data frame that we're calling it, the object name is df. I didn't go over this with you, but you learned about like creating objects and giving them a name, right? You use this little, in R we use this funny, greater than dash, which becomes basically an arrow that says take this thing and store it in this object name. So we're taking the data frame, we're storing it into the name df. And if I say, show me print df, it prints out this data frame, 6 rows, 4 columns. Okay, so we say, ggplot, I want to make a data frame. I want to make a plot based on this data frame, based on the plot df, okay? And then the first thing we can do is we can say, all right, let's also do some aesthetic mappings. Let's map a column in the data. Our column, we're going to do height. Let's map that to the x position. Let's take the weight and let's map that to the y position. Okay? And if I say create the plot, we get this. We get a blank plot. Not a completely blank plot. There's a scale that basically goes from small to big on the. We see height on the horizontal and weight on the vertical axis. And you go, wait, this didn't create a plot. I don't see any dots here. But internally, ggplot has at least created the structure, and it says, well, this is the plot that you've asked for. You never asked me to put geometric objects. You never asked me to put glyphs on here, okay? And so what we have to do, okay, so here it just says, what's happening here? Okay, when you did that AES, so you call AES. AES says this is the aesthetic mapping. We're taking the this variable name and we're putting it onto this aesthetic attribute, okay? So we've given the ggplot the name of the data frame, the aesthetic mappings, but we haven't told it what geometric objects to put there, okay? It doesn't know if we want bars, lines, points, something else, okay? So what we're going to say is draw some points, geom underscore point. This says take that and draw some points for where we have data. So we have the same plot as before. ggplot, same command, ggplot based on the data frame, take the height variable, map it to the x position, take the weight variable, map it to the y position, and add, so we have a plus sign, add points, okay? And so our 6 values appear. Okay, we can see the person, 72 inches tall, 190 pounds. Okay, on my screen, there's lines. But on here, it's like, it's all washed out. I'm sorry. You guys don't get to see it. In the slides, they are there, okay? But 72 inches tall, 190 pounds. This person looks like 68 inches tall, 165 pounds. And so, we could at least get those 2 columns of the data back from this plot. All right? You could add additional aesthetic attributes, okay? So here, we could say, you know what? I want the gender of our data set to get mapped to the color of the dot, okay? All right, so one thing we can do, right, to kind of make all of our plots easier is we could say, you know what, I'm tired of having to retype this. We could take the base ggplot, this command, and store it into some object P, okay? This object P is basically this, okay? Okay, I've taken this command and I've said store it as P, and the object P is this, okay? And then we say, okay, well, if I did P plus geom points, that's basically this, right? P is this part, and we added the point geometries, and we get this. And so we could do that, right? And now I could say, you know what, I want to add a color, and I want the colors to be based on gender, okay? So we're going to say color equals gender. And here, this is the plot, okay? And so we could see this plot is blue, 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 or aquamarine. This plot is red, red, and red. Those are the females. And this is our plot so far. Okay, so far so good. What you could also do is you can, if you don't use this function, AES. AES says take the variable, the column, and map it to this aesthetic attribute. If you don't use that, you can just use settings. So we can say size. I want my points bigger. Size is 10. Okay? when you use size equals 10, the size of the point does not represent any attribute of the data. Because it's the same setting, all the points are size 10. All the points are going to be size 10. So it doesn't represent anything from the data. Here I'm saying the color, notice there's no aesthetic mapping here. Color is just blue. This is a setting. Every single dot is going to be blue. There's no variable information, no data information is carried in the color if I use this command. Okay, so if I use this command, this is what the plot looks like. All 6 people are shown in blue. All 6 people have the same size. Okay, there's no information about the data point itself that's carried in either the color or the size. Okay, whereas over here, when you use the AES color equals gender, information about the data is carried in the color attribute. Over here, information about the data is not conveyed in the color, right? That's the difference between an aesthetic mapping and a setting. Okay? All right, you can do things like you could change the scale, and then we could say, all right, on the lower end, I want this and that and stuff like that. It looks like I'm out of time. Okay, let me give you your last view quiz answer. Last view quiz answer is E as in elephant. E as in elephant is the last view quiz answer. E as in elephant. Okay, we'll end here. We'll continue on Friday. We'll talk more ggplot stuff and data visualization, and I will work on publishing your first homework assignment soon. All right, thank you everybody. Have a great day. We'll see you guys on Friday.